So in this page we'll expand on the idea we had in the previous page, talking about two-way tables and categorical data. We'll talk about here a relationship between two categorical variables. Now we will analyze the relationship between two categorical variables. One variable is the explanatory variable. So this language should sound familiar. We talked about this previously, but it's been a while, so we'll kind of review it. One of the variables is the explanatory variable. The explanatory variable, just to refresh, defines the group that we will compare. The other variable is the response variable. We analyze the distribution of the response variable for each group. So here we're going to talk about the two-way table that represents the data. If we separate our sample of 1,200 college students from the previous page's example and compare the male and female responses, we'll find a similar distribution across body image. Oh, it's asking, will we? Sorry. That's why I like Spanish better than English, because you see a question mark at the beginning of the sentence, so you know if it's a question, right? Okay. Anyway, if we separate our sample of 1,200 college students by gender and compare the male and female responses, will we? Okay, I missed that word. Will we find a similar distribution across body image categories, or is there a difference based on gender? Now that's a good question. Kind of instinctually you imagine it, there will be a difference, right? Answering these questions requires us to examine the relationship between two categorical variables, gender and body image. We want to determine if gender explains the differences in body image responses. Therefore, the explanatory variable is the gender. So we're imagining there's two variables here, the gender, whether someone's male or female or other, and then the other categorical variable is body image, the response. Did they say they think they're overweight or underweight or just right? So we're imagining that gender will explain the answers of body image, right? So that's why they call it the explanatory variable is gender. We think that one will influence the answers. It'll explain the answers. Like if it's female, maybe more will say overweight than if we're talking about male here. Like we said, the response variable is body image. Okay. To summarize the relationship between the two categorical variables, we create a display called a two-way table. Here is the two-way table for our example. So they've already asked male, female to see what their responses are. So here's the table. We have those that are, okay, about right. So we have to kind of match it up here. We got about right is this column, and the very first row is female. So 560 females said they feel like they're about right, weight-wise. 163 females said that they feel like they are overweight, and then only 37 females said that they think they're underweight. And there were 760 females total that were asked this question. Males, there were fewer that said they're about right, 295. There were 72 that said they were overweight, quite a bit less, but there were quite a few more that said underweight, almost 3 times more almost, or 2.5, 3 times more than the females that said they're underweight. So those numbers will obviously be influenced by the raw totals. There were 760 females asked about the response, but there were only 440 males. So it's kind of, I guess it's misleading to compare these numbers specifically. 560 were about right for females versus 295 were about right for males. You can't really compare those numbers because more females were asked. So I think percentages maybe or something like that will really tell us something. Let's see, okay. Let's move a little down here. Let's take a closer look at this table, okay. The table helps us compare females to males because there is a row for each gender. The body image categories are the columns. As we move across a particular row, all the individuals are of the same gender, and as we move down a particular column, all of the individuals have the same body image. We also added a column at the right for raw totals, and we added a row at the bottom of the table for column totals. For example, look at the numbers in the female row, and note that there are, like we kind of mentioned, 760 females in the sample. We also see that in the about right column, there are 855 of the students in the sample view their body weight as about right. When a row and column cross, we see the number of individuals who fit both descriptions, a particular gender and a particular body image. It may be helpful to think of the 6 inner cells as 6 rooms filled with 1,200 students from the sample. So yeah, imagine there were 1,200 students and you had to go to a particular room depending if you were, let's see, back at the table, you were a female who felt you were about right, or if you were a male who felt you were underweight, or a female who thought you were underweight. There's 6 6 rooms. Each of these little turquoise or blue or whatever the heck color circles represents a different room. Females go into 3 different rooms, about right, overweight, underweight, and the males go in 3 different rooms. The males that are about right, overweight, underweight. So that's what they're trying to say there. In one example, for example, in one room there are 72 males who think of themselves as overweight. In another room we have 37 females who think of themselves as underweight. Maybe they should have a potluck and get to know each other. That's silly. Before we continue our analysis, we will pause to practice reading a two-way table in the next activity. So I was kind of curious about these. We could probably do the percentages here, but I have a feeling we'll revisit this again in the future.